Anyway, Eamonn, it's all yours.
Terrific. Look, thank you very much, and thank you very much for everybody who's attending. I think this is an important few presentations that I've done actually on the quantum mechanics itself, because so many people approach this from a scientific and a computer background. I think it's good to embrace the underlying physics, which I've been studying for, 10, 15, 20 years with my cosmology studies as well. And quantum physics itself is just absolutely mind-boggling. I did the presentation the other day, which we won't go into today, unfortunately, because I just love talking about it, which is the delayed choice quantum eraser, which did two things. Number one, it proved that there were two photons and the only difference between them, no other difference, the only difference was that we knew which, or in fact, we could have known which slit it went through in the double slit. The other one was jumbled up because of the eraser effect. And amazingly, the whole empirical nature of the photon, whether it be a wave or a particle, changed just by that difference. And the beauty of quantum mechanics is that we really don't understand why these things happen. But they are amazing. Obviously, I don't have to tell you guys about entanglement and how wonderful that is. But today I'm going to focus on consciousness and where that plays a part. And you may be surprised with this. The beauty of quantum mechanics is that it does embrace theology, epistemology, ethics, morals, and the actual existential existence of the universe with science. So there's an awful lot going on here, and I'm going to discuss superposition, because you all have to understand superposition, and the two big mysteries of superposition, which is the observer effect, which is essentially the Copenhagen interpretation. What happens in quantum mechanics is we know what happens, and it's actually very, very accurate. It's far more accurate than Newtonian physics or the classical physics that landed us on the moon. Had it have been powered by quantum computers, we'd have actually got, the lunar module would have landed within a centimeter. It's incredibly accurate, and it's incredibly reliable, consistent, which is why we can use it in a computer environment, putting decoherence to one side for the moment. So it's incredibly accurate, and it's just totally different, and yet we're made up of these particles. So it's absolutely amazing. So what happens all the time. Like entanglements never ever fail. But we don't know what's going on. So we have these interpretations, and you'll hear about the Copenhagen interpretation, which is essentially the observer effect. And then we have the many worlds. You've got cubism, you've got the pilot wave, and there's a number of them. At some stage, I may do a presentation on the different interpretations, because we're sort of getting closer to which is the right interpretation with recent experiments. So it's amazing. But the observer effect comes from the Copenhagen interpretation, which is done by the two heavyweights of quantum physics back in the 20s to 30s, and that would have been Niels Bohr and Werner Heisenberg, and they came up with the observer effect. And that is essentially what most of us know. If you measure or observe the wave function it will collapse into a particle. And that itself is something that obviously just doesn't happen in the classical world. But I'm going to go over that so that we're all on the same page in case there's someone who's never heard of superposition. And I'll talk about the wonderful double slit experiment, which I'm sure most of us are aware of. But then I'm going to talk about the measurement problem, which actually takes a bit of a back seat, and it really shouldn't. So the Copenhagen interpretation says that when you measure the wave function, it will collapse, i.e. when you measure the qubit, it will collapse to 0 or 1 with equal probability. But it doesn't say when that measurement takes place. And that's so important. You know, is it when the measuring device it takes the photograph, basically? Is that when it's measured? Is it measured when it reaches the eyes of the observer? Because don't forget, with the observer effect, there needs to be some element of consciousness. That's just the way it is. Einstein, the first thing he said was, well, this is amazing that it's impossible that an observer could affect the empirical form of the wave or the particle, and just by observing it. Now, if there's a little baby that happens to be looking into the camera, will that collapse the wave function? Does an animal collapse the wave function? And no, they don't. So this is why, is the measurement taking place when it gets to the brain of the person? And I'll go into that in some detail, because that's the work of, I hope you've heard of this guy, because I know all these theoretical physicists are unbelievable people, but John von Neumann, who came up with his solution to the measurement problem, and John Wheeler, just done amazing work in this area. Excuse me again. So there seems to be a conscious aspect to collapsing the wave function. As amazing as that seems, it does appear at first glance to be that. So the second half of what I'm going to talk about is a guy called Dean Radin, who's the head scientist of the Institute of Noetic Science. And for the last, since 2012, I've been following him, and from 2012, he conducted these experiments. He said, look, I'm tired of people talking about consciousness being the important thing. I'm going to prove it. And yeah, I think he's taken off more than he can chew, because the science community, the scientific community, they're not going to make this science until they're absolutely sure. Like with anything, we have to be sure of the science. And if they accept that consciousness is collapsing the wave function, then that opens the door to micro psychokinesis, the ability of consciousness or thought to leave your body and affect an external object, even at a quantum level. And that's amazing. That opens the door to telepathy, clairvoyancy, and all these things that, of course, have never been proven. I'm happy to talk to people about that, because quite often I get into a heated conversation, but telepathy has never been proven. But that doesn't mean it doesn't exist. It probably just means you're not very good at it, or that the force is contained within the quantum realm. The fundamental forces that affect our classical world, electromagnetism, gravity, the strong nuclear and the weak nuclear, which we understand very, very well, none of them exist in the quantum realm, and vice versa. Entanglement, superpositioning, and tunneling does not exist in the classical world. So gravity is the one which we're hoping is going to, the theory of everything is going to be the solution to everything. But undeterred, Dean Radin, Professor Radin did these amazing experiments, including meditators who are ostensibly more in touch with their consciousness. And he did experiments over the internet and with computer simulations, which presumably don't have consciousness, and compared that with meditators who are very much in touch with their consciousness. Now, I'm not saying that consciousness is collapsing the wave function, because there's a few dangers there, and there's a few very good arguments saying that it's non-involved. But after having said that, Dean Radin comes up with amazing facts and observations and experiments. And I believe it's scientific that if you don't know the answer, you respect other people's postulations, and it's just fantastic, interesting stuff. So let's get into it. Now, I'm just going to quickly go over the double slit experiment. I won't go into great detail because obviously you could be here for hours if we do that. Let me get the annotation now. Yeah, I just want to actually discuss what the double slit has taught us. And that is essentially the observer effect. So as we all know, we have an electron firing one photon at a time. Back in the day when Thomas Young first did this experiment, of course, he didn't have that ability to send one photon at a time. So he wasn't measuring anything. And that's why, and this is 1801, he allowed a little bit of sunlight to hit a board here with two slits and then a detector board at the back. Now, because he wasn't measuring anything, and indeed couldn't at that stage, the pattern at the back was an interference pattern. So this pattern here with multiple vertical stripes is an interference pattern. And that indicates a wave. So imagine if we pushed water through those two slits, they would touch the back slit in many places with the higher intensity in the middle and it becoming less and less prominent towards the edges. That's what a wave does. So when he did it, there was no problem or query. He just did it, and there was an interference pattern, and he said, everybody, I've solved it. Light is a wave like sound. And indeed, Maxwell's four equations, about 80, 90 years later, actually supported light as a wave. So everything was fine up until 1912 when Einstein came up with his Nobel prize-winning photoelectric effect, which basically fired light at a metal, which then displaced atoms, but it displaced atoms one at a time. It did not act as a wave. So when the intensity was increased, if it was a wave, you'd expect more atoms to be released, and it wasn't. So the important thing is Einstein proved it was light was a particle. So then we said, but Professor Young obviously wasn't wrong. It seems, he said, to act like a wave and a particle at the same time. And that's what's called wave-particle duality. And that's what a superposition is. A superposition is a wave of probability. So because of Werner Heisenberg's uncertainty principle, we cannot know the momentum and the location of a subatomic particle at the same time. The more you know about its speed, the less you know about where it's going or where it's been. You cannot know its full trajectory. And if you do, nature, not our sophisticated equipment, we have the equipment that if we were allowed to look at what's happening with the wave function, we would be able to examine it and find out what's going on. But every time we try to look at it, nature collapses the wave function. So it goes from this fuzzy wave, fuzzy cloud of probability, never knowing where it is, never knowing discrete information. And again, the analogy is like the Earth orbits the sun and it's discrete. You know where it is at any moment in time, and you can actually plot where it's been and where it will be. We know that exceptionally well. We know the orbits of all the planets and lots of the comets and things like that. So that is the classical world, and that is discrete. But in the analogy, if you extended it to the quantum world, it wouldn't be orbiting the Earth. It would be a fuzzy cloud around the Earth where it would have a higher probability of being in location A and a lower probability of being in location B. But that is constantly changing and very difficult to, well, impossible at the moment to quantify. There's an equation which, like with all waves, you can do predictions of the movement of the wave over time, and that's called the Schrodinger's equation. Schrodinger, the famous guy for the Schrodinger's cat, which just shows, again, this superposition that, and it's only a story, it's only an analogy, by the way, Schrodinger's equation. It's not to be taken literally. So it's saying in the classical world, we can't have dead and alive at the same time, but in the quantum world, we can have dead and alive, hot and cold, and one, whereas in the classical world, it can only be a 1 or a 0, in the quantum mechanical world, it can be everything in between. And I've said this before and I'll say it again. I hate it when people say in a qubit can be 1 and 0, or 1 and 0 at the same time. It's a lot more than that, as is shown by the Bloch sphere. So that's the amazing thing we have. But the observer effect showed us that whilst, until observed, the entity, the particle or the bit of light, the photon, is in this obscure wavy thing, but when we observe it, it becomes discrete. It becomes a particle. And this backboard at the back would actually just become 2 lines, as we would expect 2 lines coming through here where we're firing bullets at them. So, and that's called a clump pattern. So, and the amazing thing was, if we place a camera to watch the photon go through one of the slits, if we know the path, the location of the subatomic particle, then it collapses. We're not allowed to know, which is very, very strange. Because obviously nothing like that, again, happens in the classical world. But that's the observer effect. Now, the amazing thing is that this fuzzy cloud, we can actually use mathematics to simulate what's happening in a superposition. And a superposition, it's in an imaginary state. Only one of the states becomes real under observation. So it's an imaginary location. So how could we map to it? But we can, using complex and imaginary numbers. And Terrell did an excellent presentation on complex numbers and imaginary numbers and on the block sphere, which ties it all in together. But that's all, not all, but that's what the quantum computer is doing. It is giving a mathematical equivalence of superposition, this black cloud, if you're fuzzy cloud, rather. But this is the crux of what I'm going to speak about today, and that is, when does the measurement take place? Number one, it's crazy that a measurement or an observation should change the photon. That's just amazing by itself. But another question, which was the subject of a lot of debate, was where is the measurement, or when and where is the measurement taking place? And this has somehow been relegated to the back seat. I was watching an excellent presentation by the excellent Sean Carroll on the measurement problem, which we now call the measurement problem. And it's a phenomena that we just aren't getting anywhere with, as happens a lot in quantum mechanics. We really find it difficult to answer, but I will give you John van Neumann's and John Wheeler's, and for that matter, John Bell. That's a lot of Johns, isn't it? I've never thought that before. But John Bell, the Irish guy, who contradicted Einstein and Rosen on the APR paradox, which was, they said, they thought they'd proven that quantum entanglement didn't exist. John Bell very famously proved that it does exist, and Schrodinger's cat is real. Mathematically he proved that, but he was also spent decades looking into when the measurement take place. And don't belittle how important this is. As amazing as the observer effect is, what's making it happen? And when is it happening? Now, there's a saying, you probably heard it, there's a saying in quantum physics, which is shut up and calculate. And that is, look, let's stop trying to understand where the measurement's taking place. We know it does, and we can use that in our computers, and we can use it in wonderful ways. So shut up and calculate. But a lot of us aren't shutting up, especially D. Radin, who is determined to find this out. Now, the question is, where does the measurement take place? Is it in the equipment? Is it in the hard drive of the equipment? Is it in the eyes of the observer? Or is it in the consciousness of the observer? And whilst that sounds absolutely crazy, there's a lot of circumstantial evidence and experimental evidence to say that it is the consciousness. And when someone like John van Neumann says, as I'll get to later, he actually said, what will happen is it will be a quantum action between two parties until it reaches what he called a physical entity, which is consciousness. So he's saying, no, it doesn't happen at the measuring device. If it happened at the measuring device, I'll talk about some reasons why, or proof that he gave that it wasn't at the measuring device. In fact, it wasn't until a human consciousness let's say human, certainly the consciousness of animals will not collapse the wave function. So human or above, take that for how you will. It's not until that happens that the collapse takes place. And he said, I'm tired of people talking about it. I'm going to go and prove it. And this is what he did. Oops, that's not what he did. So what is collapsing the wave function? And again, I'll stress, we do not know, but I'm going to follow the path of Dean Radin just so that you guys can do your own research if you're that interested in it, on the fact that it's consciousness. So here's Dean Radin. He's, as I say, chief scientist at the Institute of Noetic Sciences in California. And let's put that over there. What he did was he set out to prove that it was consciousness that was collapsing the wave function, and that the collapse of the wave function happened when it was met by a physical entity, as von Neumann postulated, which is consciousness. So the first logic he thought of was, well, look, why don't we use Tibetan transcendental meditators who are purportedly more in touch with their consciousness, and see if they can collapse the wave function by meditating. So imagining the photon, obviously one can't see a photon, but imagine, so they had a time where they would meditate and attempt to collapse the photon. And then he compared that with a group of normal people, if you want to use that adjective. And the results were startling. They were, and I might add, as I've put in the slide here, he's got 80 gigabytes of results that he's made freely available to everybody. And he has also been able, I might add, to reproduce all of this experiment. So as we know in science, if you're going to make a postulation, what you have to do is show it happening, and you have to be able to do it time and time again. You have to be able to repeat the process with the same result. And he has done that. There haven't been many other experiments happening at the same time. There was a person in Brazil who a couple of years ago was trying to do his own series of experiments, but obviously a lot of money and effort and time and everything has gone into that. So not many people have done, the Radin experiment. But I can't quite remember the statistic, but it was very significant how meditators were collapsing the wave function more than ordinary people. And that makes no sense. Consciousness is consciousness, is it not? But it would appear that people who could tap in to more depth of consciousness could collapse the wave function. He then started doing it in different rooms. So they weren't, up to this time, they were in the same room as the equipment. It's a small interferometer that would send photons one at a time and measure them. And they were in the same room. And what he did was in different rooms. And when he went to different rooms, there was no difference. Then he went to different countries. So these meditators were in a different country and were, again, meditating on the collapse. And again, the difference was markedly significant. between the meditators and the ordinary people. So this was crazy. Then he did another experiment, and again, this is all documented. And what he did was he did it over the internet, but at the same time, he did a Linux program simulating the data. Because when we talk about these experiments, it's obviously not one or two. We're talking about absolute thousands over the space of a couple of years. And the data that was coming in, so somebody would remotely, a light would go on, they'd be connected to the internet, to the laboratory. A light would come on like a green light, and then they would think about which slit the photon was going through. And then a red light would come on and they would stop and relax. And all of this generated a humongous amount of data. What Dean Radin's team was, they created a Linux simulator that simulated the data coming in. And they then compared the simulated data with the data, they compared the performance from the simulation, the Linux simulation, with the performance when there was a human being doing it. Now, even though this data is ostensibly the same, it's simulated, if the results were amazing again, in that when there was a human at the end of the line, the chain, it's called the von Neumann chain, when you go through the measuring machine, the eyes, the consciousness, where's it being measured? When there was a human at the end of the von Neumann chain, it collapsed the wave function more completely than if it was the simulation. And again, this is all in the results and something he makes quite clear and he has repeated. I might say that when scientists are trying to take out any negative disturbance in the experiments they're undertaking, so that it can't just be by chance that this is happening. There are sigma ratings for this, and I think the sigma rating for finding the Higgs boson was about 3 or 4, but Dean has reached 4 sigma, so it's sort of saying there's a very, very little chance, a small chance, that this is just happening due to chance rather than anything else. So I think you'll all agree that that is amazing. And again, Dean Radin answers all the questions, and he's really sort of saying, what more do I have to do to show that it is consciousness that is doing this, that is collapsing the wave function? Now, there was the scientific researchers involved in writing the critique of the work by Dean Radin were Wolosek and von Stilfried. And this is just 2009. This is just about 9 months ago. I think it was October in 2019 that Wolosky and von Stilfried actually did, they've released a paper, and I can give links to this in the slides, but they created a paper that contradicted Dean's processing, his experiment. And I may add that Dean Radin refers to in the 30s and 40s, consciousness was accepted as the entity that was the physical entity that was causing the collapse. And people as Heisenberg, Bohr, Niels Bohr, Paul Dirac, very famous, he did antimatter. All of the top scientists at the time claimed it was consciousness, was probably consciousness. So we've lost that along the way. Now, the Wallace-Eck and von Stillfried critique basically said that there was a false positive effect, which meant that they couldn't accept the results and that further research would have to be made. And Dean Radin has responded to that. He's written a retort explaining why he believes their critique is inaccurate. And it's all down to this false positive effect, and that's like the false positive, it's sort of linked into Bayesian theory, where you have, if you've got a 40% or a 90% chance, your medical tests come back and there's a 90% chance it's this, which cancer, which means there's a 10% chance that it isn't. And then there's all these mathematical calculations that you can make. And where there is any doubt and where somebody is taking an experiment knowing the ramifications of their answers, then this false positive effect can occur. There's a very famous, and the fact that, you know, Dean Radin was then saying, well, hold on a minute, we've had different people do the same experiments and we've had the same conclusions reached. There's a very famous scientific experiment called OPERA, which was testing the, there was a postulation that neutrinos, you know, there's millions and millions of neutrinos that come from the nuclear fusion of the sun passing through us at any moment in time, most obviously not interacting with us on the electromagnetic scale, but irrespective of that, there was proof, if you like, that could be reproduced that the neutrinos were traveling faster than light. And this was science, and when we're talking about 30, 35 years ago, this was science for a number of years until it was shown that there was a false positive effect causing these results, even though it was reproducible and it had a high sigma rating. So Wallace-Eck and von Stillfried is saying, look, this is not enough. Dean Radin's going, what more could you possibly want me to say? And then he showed mathematically how their false positive effect was exaggerated. So there's an awful lot of conjecture, but I think it's a really exciting part of quantum mechanics that we need to understand, that it is part of the debate at the moment. So look, it's 7:45. I've spoken for 45 minutes. That's the end of the presentation, Terrell. Terrell, are you there?
Yes, sir.
Excellent. Look, that's the presentation. So if there's any questions, I'd be more than happy to discuss them. And when I send you the slides, it will include links to the original experiment and links to the critique by Wallace-Eck and von Stillfried, and then Dean Radin's response to that. So you'll have all the, if you wanted to do any further research into it, it can be done there. But it is, the thing is, it does on the face of it look as though it's consciousness, The only reason why we don't accept it, if you like, this is what Dean Radin would say, is that it's so crazy. But so many things in quantum mechanics are crazy. But the measurement effect is real. We still don't know the answer. What we do is shut up and calculate. But that's the discussion, the interpretation I wanted to go through today.
That was really interesting. Thanks for sharing it.
Thank you very much. Is that Thomas?
Yep, that was Thomas. Yeah, no, the whole idea of consciousness causing measurements is really fascinating. I'm going to have to look at those materials once you post them.
Oh, look, that's terrific, Thomas. And thank you for that. And it's absolutely unbelievable. The ramifications of this, and as I say, on the face of it, if we didn't have to prove it scientifically, if we just had to guess what it is that's doing it, we would say consciousness straight away. Because as Einstein said, if you've got a measurement, a human being doing the measurement, then it will collapse the wave function. If you've got a 5-year-old boy looking at the data, and he's obviously not understanding anything, it won't collapse the wave function. So that's very, very strange. But yes, I'll make sure you get all the material.
So Eamonn, Keeper here.
Hello, Keeper here.
Hello. So super fascinating. I recently came across a video on deep sea diving and holding the breath and what that has to do with meditation and consciousness, and how we're able to communicate with marine mammals, sort of like they are able to approach us if we do this deep sea diving without any equipment. And they were talking about, how, whales and dolphins use this really sophisticated communication with acoustics and wave mechanics and, sonar. And it fascinates me that we've come to the conclusion that humans or above, as you said, are the only ones that are able to, interact with the collapse of the wave function. And I'm wondering if we've tested this idea on marine mammals or not.
Great question, and I can't answer that directly. I can say there have been extensive tests done with animals. I definitely know dogs and cats were done, and they could not collapse the wave function. And whether marine mammals can or not, or whether they've been tested, I don't know, but it would be very interesting. Aristotle, 2,000 years ago, said the one thing we'll never understand is consciousness. And he's so far right. Because we don't know, is consciousness a function of the brain? Does it wholly lie within the brain? Or is it external? Do we tap in to consciousness as we tap in to the internet? And then, so is it an emergent phenomena, or has it always been there? Did it precede the Big Bang? Did it come into existence at the Big Bang? That there are many, many questions, and we simply don't know. So it could be a set of chemical reactions that are providing consciousness, and a particular set, oxygen and carbon and Yes.
the various elements that, if we're made out of the stardust and we're it's a part of us, it could be the stuff itself that is conscious of itself, and we're just the human manifestation of one particular solution to some massive life problem.
Yes, so you're quite right. I mean, by saying it's a chemical process, which there's a lot of evidence that it is one part of it anyway, then you're saying it is within the brain. It's a chemical process, which we don't understand, but that is all it is. But a lot of people
Well, also to say that just because it's the reaction may be taking place in the brain doesn't mean that it has some sort of fuzzy experience outside of the body, right?
Through right.
You know, the probability distribution in space. That even though it's in the brain technically, the majority of the existence, there's, you know, this possibility that the overlap and the wave function, you know, embodies something that's much larger than our physical form.
Yes. Look, we don't know is the answer. So,
Eamonn, there's Nixon. I had a couple of questions. I don't know.
Oh, hi, Nixon. Yes, please.
You could see on the chat. But before the question, answering or commenting on what Keeper said, if that was correct, then the animal brain or mind should be able to collapse the wave, right? It's a function of the brain itself. So I think it's beyond that. It's more to do with the free will that the human mind has versus the other mammals which do not have a free will. So that's a comment. But my question goes, if you can...
Sorry, Nixon, just before you get on to your question, the issue of free will is a huge Pandora's box in theology, obviously. There's a lot of very, very intelligent people saying that we don't have free will. And there's a lot of arguments to and fro, you know, the metaphysical, which I'd love to talk to you about on another occasion. Probably best not to go into it now. But
what else would be the difference between the human mind being able to collapse the wave versus the other mammals not being able to do that, right?
Well, yes. I don't think it's free will. I mean, and again, this is just my own personal opinion. I don't see why it would be the fact that we ostensibly have free will, because there's counter arguments to whether we do have free will or not. And I might just add, I'm sorry that I can't look at the chat at the same time. So I'm sorry if you've asked this question earlier. But no, so whether we have free will, I don't think is an issue. But our consciousness is obviously on a higher level than the consciousness of animals. They do have consciousness, there's no doubt about that. So is there a threshold? So a little bit of consciousness won't collapse it. Human consciousness will. It's all very weird and strange. But please, your further question?
Yeah, I had say existence, I'm reading it out. I thought you could see the chat. Existence of a living being is from the grossest to the subtlest, is from body to intelligence, which is brain, mind, and consciousness, right? Since consciousness is the subtlest and not bound by space and time and other restrictions, how could the existence of such entity be established positively by more gross entities like the mind and the brain, right? Which are more limited. That's question one. Second part, could it be that the consciousness entangles with the mind, and when it does, meaning the consciousness decides to do some measurement, is when it sees some reaction from the mind to observe the event, and that collapses the wave, and that's how the observation happens?
Well, to answer your second question, to answer the first question, nobody knows. To answer the second question, yes, there is a school of thought that discusses that the observer becomes entangled with the system. And this is an interpretation that leads to the many worlds interpretation by Hugh Everett, which is very much supported by Sean Carroll. And the guy, Hugh Everett, was a mentee. His mentor was Niels Bohr, and he was ridiculed for talking about the many worlds theorem. Now, the many worlds interpretation of quantum mechanics is that you become entangled with the experiment, with the photon. So you're in one reality, but elsewhere, there's no collapse. So you're having an individual relationship, if you like, with the photon. And in your universe, your reality, it's collapsed, whereas in other realities it hasn't. And it keeps branching off and forming all these different worlds. And I think I mentioned last time, there's been some, again, just within the last 12 months, fantastic research by Massimiliano Proetti in the University of Edinburgh, who has basically proven that you can have two realities in our universe. We have always thought there's one reality, it's an objective reality. And how, and then we interact with that reality, but that reality is the same for everybody. But he has proved, what he did was entangled photons. He had a local person not measure the wave function, and he had a remote person measure an entangled photon of that photon. So he was remote. So for the reality for the remote person was that it was a particle. The wave function had collapsed. The reality for the local person was that it hadn't collapsed. It's a thing called, it was a Gedanken, a thought experiment by John Wheeler and a guy called Wigner. It's called Wigner's Friend. And I do recommend you look that up and look up because it's like saying, I have a reality where I come into my study here and there's no wardrobe, and then Keeper goes into the study and she sees a wardrobe. No, that's, hey, it's strange, but there's very good proof now that at a quantum level is what happens. So your point that consciousness is an entangling with the photo and subsequently collapsing it, it makes perfect sense.
Yep, thank you.
Pleasure. Nice to talk to you.
Let's save you. So,
any more questions for anyone?
Since nobody has a question, I'll ask you another question, which is...
Oh, please do.
Which is on a fringe of science and philosophy. So,
yes, it is.
So it comes from a very old text, which I studied like about 10 years ago. So it talks about the various stages of human, right? Like the waking state, the sleeping stage, the deep sleep, or the, where you're like, kind of not aware, right?
Yes.
And then there's the next stage. So if in the waking state, your gross, your mind, your brain, everything is active, and you're aware of that. In your dream state, you tend to lose awareness of your the gross element, the body. Like your senses kind of withdraws, and
I understand.
Conjuring it to your brain. Some mind is creating some parallel universe. You're the creator there, and you're the sustainer. You're the destroyer. You wake up, you destroy it. But then beyond that, there's the deep sleep state, which is when you don't even dream, right? So obviously there's something there, the consciousness, or what do you call that, that's keeping that thing going. Because if the body didn't have that consciousness, like a dead body, when somebody dies, you still have the brain, you still have the mind, you still have the gross element, and that particular entity, the body, which is dead, does not show similar kind of activities. So the question here is, even though it's being very subtle and not accessible to more gross elements like the brain and the mind, this consciousness, if just the collapse part of it or the entanglement part is be considered, what happens when the body dies? A human being dies.
Yes. Yes, well, that is getting back to, does consciousness exist externally to our brains? So that if the person dies and consciousness is within the brain, is a process of some, the synapses and the neurons, etc., etc. And by the way, quantum entanglement plays a big part in your brain and the brain of animals like bird migration. Quantum microbiology is a very interesting subject. I might just add that. And we're beginning to realize that things like tunneling and entanglement and superposition do occur within the brain. But if consciousness is an element outside this, and I might also add up, I might also mention universal consciousness, which is that we are all one huge wave function,
Mm-hmm.
but we don't realize it simply because of locality. So I am you, and I always quote John Lennon, I am you as you are me, as you are we, and we are all together. He got it right somehow. We are all the same entity. We just we're in different parts of the wave function. And so what we we're not conscious of that universality. But if you go back to the Big Bang, and it must have started from a quantum particle, which may or may not have been observed, we can talk about that forever as well. But there's a school of thought that everything at that moment was entangled. So the fact that we had this Big Bang, it actually wasn't a bang, it was inflation, which is repulsive gravity. So it's gravity working the other way, which is dark energy, which is why our universe is still expanding, and it's accelerating its expansion. And that's a fact. We've proven that by exam. In fact, an Australian scientist in University of New South Wales got the Nobel Prize for the fact that we've only known for 10 years that the expansion of the universe is accelerating because of this dark energy. But at one stage, everything was entangled. So there's a school of thought to say that everything is still entangled because time and space do not affect entanglement. We know that. So it stands to reason that everything is still entangled. And if everything is still entangled, then that leads to many different possibilities with consciousness, i.e. there's an entanglement and there's that connection which is external to our actual brain, because it's all part of a bigger picture. And I hope that didn't sound too airy-fairy. I might add, I'm very much scientific. And when I'm talking to these spiritualists, they always say, they quote old texts, like you did yourself, Dixon, which is fair enough, I know that. But they quote, Buddhists have known about entanglement. They've been talking about it for 2,000 years. We're just catching up. And they've known about quantum mechanics for 2,000 years. And I'm not going to say they're right, they're wrong, whatever. Because actually they have been talking about a universal consciousness. And the old texts do talk about, as you were saying, waking, sleeping, aware and unaware. And that is essentially what's happening. My own opinion is that's looking at the facts there's a false positive coming in here. It's easy to go back and make an interpretation, a bit like Nostradamus in his interpretations. There's going to be a big fire, and then people start saying it was 9/11, etc., etc. So one has to be careful about that. But there is this. The whole point that I wanted to get over today was this amazing quantum mechanics, this phenomena that we're really, really struggling to understand, is the underlying reason why computers, like Richard Feynman first spoke about, using these amazing forces can do amazing things. And where we're going to be, I believe, in quantum computers in 100 years' time, whatever that number is, will not only change processes and the mathematics of things, they will change us as a human entity. Any more questions from anyone?
I have a joke question.
Oh, hi, is that Amir?
Yeah, hey, Eamonn.
Hey, how are you, mate? Nice to hear from you, as always.
Yeah, likewise. All right, thank you for the presentation. Piggybacking off of something earlier you said about human consciousness collapsing the wave function. What about the dolphins?
Oh, well, that's near enough what Keeper was saying. I'm not sure. I would be, I'm very confident that they have been tested and that they couldn't collapse the wave function. If they could, we would know about it. So no animal has ever been able to collapse the wave function. I haven't read the whole 80 gigabytes of research that Dean Radin did, but I do know dogs and cats would definitely measure. And you can even just imagine it physically. They can't look into a camera, you know, if that was the test. So it's never been proven, which obviously doesn't mean that they can't. But I think I'm right in saying, Amir, that no marine mammal, no dolphin, no anybody except for a human has collapsed the wave function. If indeed human consciousness is what's collapsing the wave function. Because that's not science at the moment. Although Dean Radin would say, you know, what more proof can I possibly give? I have contacted him. He's on LinkedIn and tried to have a chat and maybe get him to discuss things, but he hasn't replied as yet. But to answer your question, no animal has collapsed the wave function. We'd hear about it.
Yet.
Yet is a good word. It's the whole thing about this is that we don't know, and quantum, since scientists first probed inside an atom over 100 years ago, the greatest minds, Paul Dirac, Einstein, Bell, Born, von Neumann, Wheeler, no one has been able to, you know, put their finger on what's going on. And it does seem as though it's nature that's stopping us. We can't investigate any further because nature doesn't allow us. And then, of course, an extension of that is that soon quantum computers will control our society, and we don't understand what's really going on. So it's great to look at the underlying quantum mechanics that's happening with quantum computers, because that's what all quantum computers are the harnessing and the mathematical representation of these forces.
Well, I'd like to end with this thought. You know, there's guys like Einstein and all those guys who spent their whole lives thinking about this and who were unable to figure it out. I mean, the way I look at it, they don't even know Python. So, you know, I mean, really. Anyway.
That's a good note to end on, that word of philosophy.
Yeah, I mean, how up to date are they really? Or even more, man, if I can just keep rolling with that, a Jupyter notebook. You know? I mean, how are you going to figure out the world if you don't know how Jupyter notebooks work?
Yeah.
All right. Anyway, thank you, Eamonn.
Pleasure.
Very thoughtful or thought-provoking.
Thank you, yes.
talk, and I'm sure we'll be spending, all of us will be spending for the next couple hours processing this. If not, I'd be surprised. Anyway, thanks for doing this once again. And everybody, thank you for your participation today and interesting conversation as well. So we'll have another meetup again sometime soon. Just obviously check Quantumapalooza for the next show, either here in Philadelphia and Harrisburg or somewhere else around the planet. Eamonn's got a few going. You've got a few events coming up weekly,
yes,
right? Tell us about that real quickly before we check out.
It's called, thank you. It's called Quantums and Answers, a play on questions and answers. And I'm really just talking the basics of quantum computing and quantum physics with an audience that is gaining popularity. So I talk for half an hour, and then they can ask any questions on any facet of quantum computing or the actual underlying quantum mechanics. And I'm also doing a talk with Community, Community with Anisha.
Oh,
so,
you line that up, huh?
Yeah, I think she's going to be in touch with you, or she's expecting you to include it.
Yeah.
On Quantumapalooza. So either if she doesn't get in touch with you over the next day or two, it's about the 28th of July or something like that.
I'll see the announcement when it comes out. So
yeah.
I'll add it. Great. I'm glad you could line that up.
Yeah, excellent.
All right. Well, Quantums and Answers, I think the next one is on Wednesday at 7 a.m. Eastern. So those of us in the East Coast, no problem. Probably be a push for the West Coast, but those West Coast people wake up early. So it shouldn't be a big deal.
I have a tendency to do that.
Yeah. Sometimes you got to go the distance if you want to get some answers, right? All right, folks. Thank you. Eamonn, thanks again.
Thanks, Tel. Lovely to talk to you. Thanks.
We'll see you all next time.
Thank you.
Good night.